All right, so if you'll notice right here at the top, what we're talking about today is transformations of our graph. So if you remember, what was it? 3.2, I think, when we looked at all the different graphs, we looked at the linear, the absolute value, quadratic, all that. So what we're doing is talking about the transformations of these graphs, what happens to them, what does the equation look like when we move them from left to right, up, down, when we flip them upside down, when we stretch them, or we compress them. Okay, so that's kind of what we're talking about today. We're going to look at a bunch of different ones and look at what happens to the equations when we do that. So at the top, you'll see there's a couple of blanks that you need to fill in. The transformations are when we use modifications of the graphs of functions by shifting them is the first one. And that is going to be either horizontal or vertical, so left or right or up or down. And then also when we stretch, reflect, wrong word. Reflecting or stretching. And then if you'll notice in parentheses, it says compressing. Stretching and compressing is either making it really tall and skinny or making it wide and fat, kind of. It's the best way I can explain it. Okay, so stretching would be like this, and then compressing it would be like that. So we're going to start with the absolute value function, and you have the original parent function graph there for you. What we're going to do is we're going to take a look at a couple of different graphs, different equations. We're going to plug some numbers in. We're going to graph them and see what effect did that addition to the equation do to it. So if you'll notice, the f of x equals the absolute value of x. Again, that is our parent function. That's this one right here. So we're going to start with doing the same thing, but it is going to be the absolute value of x and then a plus 2 on the outside of that. So we're going to start by doing those 5 values in our t-chart, -2, -1, 0, 1, and 2. And we're going to take a look at this graph and see what happens to it. So if you'll kind of over to the side somewhere, write your little t-chart. We're going to plug in our 5 values. Sometimes we may have to add a couple more numbers. We'll have to see. That depends on if we get the actual shape of the graph that we need or not. So take a minute, plug each one of those x values into your function, take the absolute value of that number x, and then add 2 to it. That will get your y values. And that'll give us some ordered pairs to point on our new graph. And then we can kind of compare it to the original and see what happens. What does that plus 2 that is outside of the absolute value bar do to it? So again, we're plugging the number in. We're going to do the absolute value of whatever number we're plugging in, and then adding 2 to it after that. So what is the absolute value of -2? 2. And then if I add 2, that gives me 4. Absolute value of -1 is 1, and adding 2 gives me 3. Absolute value of 0 is 0, plus 2 would be 2. Absolute value of 1 is 1 again, plus 2 gives me another 3. And absolute value of 2 is 2, plus 2 more gives me 4. So take a minute, plot those points, and we want to take a look at what actually happened to my graph when I did that plus 2 on the outside of that absolute value. How did my graph move from the original one that you have up there to the new one that we have? Okay, so we're plotting our points, -2, 4, -1, 3, 0, 2, 1, 3, 2, 4, and we're just going to connect those dots and put arrows on either ends. And then look at that graph. Excuse me. And tell me what happened to it versus the original. What did this one do? What did that plus 2 make it do? It made it go up 2, okay? Does everybody see that? That vertex, the point there that is called the vertex, it just shifted up 2. Now we're going to do the same thing, but this time we're doing a number inside of the absolute value bar. And we'll talk about what's under it in just a second. Okay, so do the same thing. Do your t-chart. Choose your same 5 values. This time, I'm doing x, and then I'm doing a -1 inside of my absolute value bars. So plug it in, -2 minus 1, take the absolute value of that. -1 minus 1, take the absolute value of that, so on and so forth. And we'll see what happens to our graph here. What do you get when you plug in -2? Yeah, and then the absolute value of -3 is 3. Okay. What about -1? We get -2, so it would be 2. If we plug in 0, we get -1, which is 1. We plug in 1, what do we get? 0. And if we plug in 2, we get 1 again. So -2, 3. -1, 2. 0, 1. 1, 0. 2, 1. When I draw that, even though I don't have like an even number of points on either side, is it still the same shape? So when we graph it, even though we don't have as many, we can still extend our arrows as far so that it still looks like a V, because any absolute value graph is always going to be a V. What did this one do? It moved, which way did it move that? To the right. Okay, so in my absolute value, it was x minus 1, but my graph moved to the right one. Is to the right usually where negative numbers go? No, they go to the left, right? So we have to be very careful with these horizontal shifts. So let's go back to this one where it moved up to. If you'll notice, right below that, it says your function and then some number plus c, just like the graph that we first did. Moved my graph where? Up, okay? So if you take your function, whatever it is, whether it's an absolute value, quadratic, cubic, anything like that. So for example, absolute value plus some number makes it go up. If I were to do minus some number, what do you think that would do? Go down. Okay, so this one goes up, this one goes down. And it would be the same whether it's a quadratic or absolute value or any kind of parent function. If you're adding or subtracting it behind the original function, then that's going to move it up or down, okay? And then, so the next one, again, f of x minus c moves my graph down. And then under there, it just tells you adding or subtracting outside the function is a vertical shift, moving it up or down. And it is exactly what the sign is. If it's a plus, it's going to move up. If it's a minus, it's going to move down. Does that make a little sense? And then looking at the next one, it moved to the right one, and there was a minus in my parentheses. So here's what happens now, is if we take that c and we move it inside of our function, so like inside the absolute value or inside your quadratic, if it is a plus c, it is going to go to the left, okay? If it is a plus c, it is going to go to the left, which is not what we're used to. Plus is we're used to going to the right. But when it is inside your function, it's going to be opposite. And then if it's x minus c, then it is going to go to the right. And this is where we need to pay attention. When we do it inside of the function, you're going to go the opposite of the sign. If it is a plus, you're going to go to the left. If it is a minus, you're going to go to the right. Anybody have any questions so far? Okay, what I would like for you to do is do the same thing for the next two graphs. Use your T-chart. Pick the same 5 values, -2, -1, 0, 1, and 2. Plug those in. Let's graph them and see what happens to these. On this one, I have a negative in front of my absolute value, and then I have a negative inside of my absolute value. So what we want to do is see what happens to these. So if you will, take just a couple minutes, choose your 5 values, plug those in, simplify it out. And let's take a look and see what happens to our graph. how the 2 is on the outside of the absolute value. So what you're going to do is you're going to plug that number in. You're going to take the absolute value first and then add 2. And here the 1 is inside the absolute value first. So you have to do plug that in. You have to do -2 minus 1 first and then take the absolute value. Yeah. So you can't get it through that screen, is that what you're saying?
You did. I was finished.
Did you go to your way equals? I just turned it off and turned it back on. So what is it looking like that negative in front of my absolute value bar is going to do? Flip it upside down, right? I used to go the other way. Let's see. All right, so if I plug this one in, think about this. You're going right here. You're plugging in, there's a negative outside the absolute value, and then you're plugging in -2 inside. So you have to do what's inside the absolute value first. What's the absolute value of -2? 2. And then you multiply it by that -1 in front. So what would that end up giving you? -2. What would you get if you plugged in -1? And 0? And 1? And 2? Okay. And so we're going to plot those points. And so basically, if you look back to that original absolute value function, all it did was went and flipped upside down. The vertex is still in the same position, it's just everything else moved upside down. So that negative in front of your function, this is what we call a reflection. Okay, it's going to reflect it across which axis goes horizontal, the x. Okay, so this is called reflecting on the x-axis. It just basically takes the whole thing and flips it upside down. Now, we're going to do the same thing, but to the other piece. Same 5 values. And then this time when I plug it in, there is a negative inside of the absolute value, but when I plug in that first one, it's also a negative, right? What does a negative turn? Positive, and then the absolute value of that is just 2. So this time it's always going to be positive values. So that will be a +1, 0, +1, +2. Does that one look any different than the original? No. Okay, technically this is a reflection, but it is a reflection on your y-axis. Well, when you've got both sides on either end, you just do like this, it doesn't really change, right? Reflecting on the x-axis goes upside down, but reflecting on the y-axis just basically turns it around. And so if it's even on both sides, it's not going to look like it changes. So a lot of those you won't be able to recognize if you're looking at a graph that has been reflected on the y-axis, but it also depends on where the negative is. If the negative is outside of my function, it's going to reflect it on the x-axis, flip it upside down. If the negative is on the inside of my function, it is going to reverse it on the y-axis. And these types of graphs don't change. Some of them will, but these types don't. Is everybody okay with that? So flip that over at the top. We're going to write all this stuff down that we just talked about. Again, if the negative is inside of my function, then it is going to reflect it about the x-axis. And again, that just looks like it's been flipped upside down. Your notes are on your desk. And then if the negative is on the outside of the function, okay, in front of the entire function, that's when it reflects about the y-axis. Ben, did you see that? Anybody have any questions so far? So let's take a look. Let's kind of put them all together real quick. We haven't finished all of our transformations, but I want to. And again, we're just using the absolute value as an example. This works no matter what it is. So again, if your function is just the absolute value of x, you're going to have multiple shifts that can occur. Plus c moves it up. Minus c moves it down. Okay. Remember, this part is just the name of it. We're really focused on here. What's happening here is the number being added or subtracted inside or outside my function. And then, if we do it inside, that's when it goes opposite. So if it's a plus, it's going to go the opposite direction, so that moves it to the left. If it is a minus, then that is going to move it to the right. And then, if there is a negative in front of my function, that reflects on the x-axis. This is just a summary of what we've done so far. That's all. And then if the negative is inside of my function, then it reflects on the y-axis, which is much harder to see sometimes, or sometimes you can't see it if you're just looking at a graph. Okay, so that's what we've talked about so far. If it's adding a number outside of the function, then you're going to move it up. If it's subtracting, you're going to go down. If it's adding a number inside, we go to the left. It's always opposite when it's inside. If it's subtracting, we go to the right. Negative in front reflects on the x-axis. Negative inside reflects on the y-axis. So if you look at those next two, it says, what axis has the function been reflected upon? Okay, I switched it to a quadratic function. So is the negative inside with the x before the square gets applied, or is it outside? Sorry, meaning is it in parentheses or is it not in parentheses? That's the difference with quadratics. Take a look here. This is a negative, and then the absolute value of x that reflects on the x-axis. And then this time the negative is inside the absolute value. So think about inside a parenthesis with a quadratic. What do you think about number one? What would that reflect on, x or y? The x, yeah. This is the x-axis because it's a -1 times x squared, kind of like this one is. A -1 times the absolute value of x.
On the paper, no, it's supposed to be the y on top. For the lens.
Oh, I did. Monday brain, sorry. Thank you for catching that for me. Y'all fix that. I made a mistake. Inside is on the y-axis, my bad. I'm confused and y'all telling you two different things. And then outside is the x-axis. I thought you meant I had a typo, and then I realized what you're talking about. Thank you. Does that make a little bit more sense now? The negative is in front of the x squared, but that negative is not included in the squaring, therefore that's the x-axis. And then number two, do you notice how the negative is inside the parenthesis and the square is on the outside? That one would be reflected on the y-axis. Try 3, 4, and 5. Tell me what transformation has occurred. Has it moved up? Has it moved down? Has it moved left? Has it moved right? Just based on the equation. Is it reflected on the x-axis? Is it reflected on the y? And when we describe its transformation, let's say the first one we did, it went up 2, right? So that's what you're going to write, up 2. Okay, if it went down 3, you're going to write down 3. If it went left 5, you write left 5. So not only the direction in which way it goes, but also trying to get it moves that way. 3, 4, and 5 right now. Where did the transition happen? Did it happen inside of my function? Did it happen outside of my function? Was it a negative in front or a negative inside? Oops. Okay, with number 3, let me ask you this. What's my original function? Y equals what? What's there? X squared, right? So then it has a minus 2. Is that minus 2 after it's squared or before it's squared? After, okay? So that's going to be like this. So if it is your function, which is x squared, and then a minus a number, that means it's going to go down. How many is it going to go down? 2. Yep. So the transformation for this one is down 2. Does that make a little bit of sense? For number 4, I also have an x squared, but I have a plus 3. Is that plus 3 after we square it or before we square it? Before. So if it's something plus c before the function has been applied, so in this case it's squared, then that means it's going to move it to the left. And how many to the left is it going to move it? Okay. You kind of get the idea of what we're doing? Number 5, I have y equals a negative x. Is that negative after I square it or before I square it? Is the negative outside or inside? Outside. If it's inside, what is it going to have around it? Parentheses. So since there are no parentheses, this one is reflected on the... Okay, sometimes there's only one shift. Sometimes there are going to be multiple shifts. You have to pay attention to where it happens in the function, and then that tells you where it's going to move. Is everybody okay with those first 3? All right, now 6, I changed it up a little bit. I did the square root function, and I notice I have a negative. Is that negative on the outside of the square root or on the inside? Inside, so that one's going to be reflected on the y-axis. Yep. I could spell might help. With number 7, I have the square root of x plus 2. That's all under my square root. And then a minus 3. So I have 2 shifts here. Let's start with the one inside. Okay, if it is a plus 2 inside of my function, which one is this one? Up, down, or left or right? Left or right. Okay, inside my function, and it's always the opposite of what the sign is. If it's a plus, you're going to go to the left. If it's a minus, you're going to go to the right. So what is that one going to do? Go to the left, how many? Okay. Oops. Try that one more time. Left 2. And then I have this minus 3 outside of my function, out from under the radical. So if the number is outside of my function, it's going to move either up or down. And this one is the sign that it is. If it's a plus, it goes up. If it's a minus, it goes down. What is this one going to do? Go down 3. Okay, try number 8. This one has three transformations. So 3 different things happen to it. Break it down piece by piece. Do I have something outside of the function moving it up or down? Do I have something inside of my function moving it left or right? And then do I have a negative outside reflecting on the x or a negative inside reflecting on the y? Start at the beginning. What's the very beginning of my function? A negative. Is that inside or outside? Outside, so that's going to reflect on the, okay. Then I'm going to go to the next part. This is a -1. Is that inside or outside of my function? Inside, so that means it's going to move to the right one. And then I have this +4 on the outside, so that's going to move it up 4. Yep. Make sense? Kind of, sort of. Got to get used to where the numbers are. Inside of your function, or are they outside? That determines what movements happen. Now, what I would like for you to do is take a minute and graph the next function. F of x equals 2 times the absolute value of x. You're going to choose your same 5 values. This time there's a 2 being multiplied by my function. I want to see what happens to that when we graph it, comparing it to the original. So you probably have to flip back over to see if you can tell what is happening. If I plug in -2, what do I end up getting for my y value? 4. If I plug in -1, I get 2. 0, I get 1, I get, and 2, I get. Okay. And I'm just going to put this, the original one in blue. You don't have to. I just want to see if you can tell the difference with it. So the original absolute value function I'm graphing in blue. The red one is the graph of the 2 times the absolute value of x. So your normal graph is like this. What did the 2 do to it? It made it taller and skinnier, right? That's what we call stretching. Like, think about your stretching up, like makes it taller and skinnier. Does that make sense? Now, when we do this next one, what's in front of my absolute value this time? A 1/2. So should I be a little bit more particular about what kind of numbers I choose? I should probably want to choose what kind of numbers. Which ones multiply by 1/2 pretty well? Which ones are divisible by 2? Even, right? So on this one, I want to choose some even numbers. So I'm going to do -4, -2, 0, 2, and 4. I want you to use those values to graph this one, and let's see what happens here. Okay, I chose the even numbers because of the 1/2 in front of it. Multiplying by 1/2 is the same thing as dividing by 2. Making half of something is exactly the same as dividing it by 2. So that's why I chose those even numbers. You're welcome to choose 2, 1, -1, -2. It's just you're going to have to deal with trying out the fraction. So we want to make our job a little bit easier. If you're okay with graphing fractions, you can use the 5, -2, -1, 0, 1, and 2. Absolute value of -4 is 4. What's half of 4? 2. Absolute value of -2 is 2. Half of 2 is 1. 1/2 times 0 is just 0. I'm going to again put the original one in blue just so you can kind of compare it right here. The red one is the actual the graph of the function 1/2 times the absolute value of x. What did it do to it? The normal one is like this, but the new one is wider, right? So that's what we call compression. It's like you're compressing it down on the x-axis. Stretching up to the y, compressing down to the x. Okay, so let's fill in. A vertical stretch or compression is when you take some number c and you multiply it by your function. It just depends on what that c value is. A vertical stretch, making it tall and skinny, is when your c value is greater than 1. Okay, any number bigger than 1, that's going to make it get taller and skinnier. A vertical compression, to make it get wider and fatter, is going to be when my c is less than 1. Okay, you can't say a fraction because sometimes they write improper fractions, so you just want to make sure that that value is smaller than 1. So bigger than 1, it's going to make it tall and skinny, stretch it. Smaller than 1 is going to be a compression, making it wider and fatter towards the x-axis. Okay, stretch bigger than 1, compression smaller than 1. So take a minute and answer those questions 9 and 10. Is it a stretch or is it a compression? Based off of the number that you're multiplying by your function. What am I multiplying number 9 by? 4. Is that bigger than 1 or smaller than 1? Bigger, so that's going to be a stretch. And then what about number 10? I'm multiplying it by 1/4, so that would be a compression. That's it, right? That's at the bottom of the notes, okay.